I can also have fun with this projector. Check this out. Do you suppose that LCDs, that the LCD element here that's shining through, right, uses polarized light? Do you think? Yeah, I think so, right? It's like I could change this. So yeah, LCDs, they do deal with polarized light. That's how they work, is that they polarize light. Try looking at your calculator. Turn your calculator on and look at it with your, or any screen, like these screens. Try that. Rotate it and look at that. Does that do anything? Not so much.
Well, if you do it
a little bit
diagonal, it's lighter.
Yeah.
Darker.
Yeah, so those screens use polarized light. Yeah, pass them back. No, only the first person in the row. Me. Yeah. Right. So here's a picture. Here's a picture that someone's taken just to demonstrate polarized filters, and like why you should buy someone's polarized filter, right? Here you can see glare off the water and off of this, and that's because there's no polarized filter. Here you can see what they've done is they put a vertical filter over the camera. Polarized filters on cameras, you can just spin freely, right? You thread them on and then you can spin them any direction you want. And basically, they're just very cool. You can do cool things with light. Everything is sort of shiny to some degree, rocks, everything. And you can mess with the light with polarized filters, which is kind of cool, right? And then is Brewster's angle, do we need to learn Brewster's angle? I'm trying to see. Yeah.
Is this how your TV tint works?
The TV tint? No, I don't think so, but yes, it is in there. That's interesting. N2, N1. Okay, so if it's for air to something, they apparently want you, they've got this formula in the data packet. There is an angle at which it's entirely polarized, and that's Brewster's angle. And they want us to be able to do that. So let's write that one up there. In general, Brewster's angle is N2 over N1. But if you're going from air, okay, if this guy is air, right? So it's coming from how about polarized glasses? Which way are polarized glasses polarized for fishermen? Because what they let you do is look through the water and see the fish. Yeah, they're vertically polarized, so they block the horizontal polarized glare. Right. So if you're going into water, basically the Brewster's angle, the angle at which it's almost entirely polarized, is just going to be N. Right. So Brewster's angle for water, 1.33, is the tangent of the angle. Right. So the angle is tan minus 1. So for water, it should be 1 divided by, or 1.33, 1 point. The angle is like 53.1 degrees. That's the index of refraction of water. I don't know if I have a polarization. Okay, so the first question, and let's try this on the whiteboards. The first question is 120 watts per square meter of vertically polarized light. So it's already polarized, so you don't have to do the 1/2 off, you know. You don't have to do the, take off half the. I know, that's sad, right? So put the 120 in here. Yeah? And it's just going to be 120 cos squared 21, right? Once it gets to the back, pass it to the front. Yeah, that's right. Yeah, that's right. One, two, three, 4, 5, 6. We got them all. I think there's one question like that on there. That's right. That's right. Check the review PowerPoint. Yes, yes, yes. Yeah. I haven't even gotten to the sexy stuff. There's sexy stuff. We're not even supposed to talk about it. Sometimes you got to talk about the sexy stuff. That's right. Yes, yes. Yeah. Yep. Let me tell you, though, what kind of problem it is, because I can't remember what kind of problem it is on the test. It's just one question on the whole test. A subwoofer. Perfect. Okay, there we go. That's right. The problem that's on the test, and it's stuffed on the first page because I didn't know where to put it, okay, is one with two filters. So you have to do the take half off, just like the example we did. Half off, and then take that half and do this with it. Yeah, right. So it's not like this. This is like the last half of it. Right. Yeah, and it's in the data packet. Yeah. So, and I even put on the little thing I saw. I put a little reminder. I said, remember, half doesn't make it through the first filter. There we go. I want to get to the sexy stuff. What? Yeah. So no more whiteboard problem? Yeah. I know. It's sad, really. You ready? All right. Now, I can't see the clock. How much time do we have? Oh, we got just the right amount of time. All right. Let's get to the sexy stuff, and then we will, if we have time, get back to the less sexy stuff. So, the salmon watch glasses. Which way are these filters? To watch the salmon, we've polarized the light which way? Vertically. This must be vertically polarized. Yeah? Indeed it is, yeah? All right. Now, are you ready for this? I don't know if the world is ready for this. Watch this. I'll put these guys on there. Okay? Now, here's the weird thing. Is that some materials, usually organic materials, right? Like plastics and stuff like that. Organic just means it's made of like carbon chains, right? Okay. Organic compounds, a lot of them have something called optical activity. Optical activity means that as light travels through them, their plane of polarization rotates. Now, if the light is randomly polarized, you'll never notice our optical activity. It's like, what is random rotated? Well, it's just still random, correct? Okay. But if I put a polarized filter, now the light going through this bits of plastic, I just took an overhead transparency and chopped it up on it, right? Now that light is vertically polarized, and if I take another filter and put it on top, you can see that there's pretty colors. And then if I rotate the filter, and the second filter, by the way, is called the discriminator in this case, right? Okay, if I turn it, you can see that for some of them, the plane has been rotated some amount, hasn't it, right? So like that backward, that one on the back, the big one, right? Right now is looking the brightest, isn't it? We can measure the rotation of the angle of polarization, and it's quite a bit, right? And indeed, it's different amounts because they're overlapping different amounts. So this is kind of cool. Isn't that cool? Your parents, back in the day, this is what they did. They'd go to laser light shows because there wasn't Facebook, right? So they go to laser light shows and they listen to Inagata